to the evolution of the system. So that's has a fundamental role in governing the behavior of the system. If we change contact rate, would this behavior of this model change? Yeah, you bet it would. So those are kind of part of the governing processes of the model. We talk about them as kind of driving the model. They're associated with the factors that shape the evolution of the model. By contrast, there are factors like color, which are mixed in there, but they're epiphenomenal. They're associated with observer processes. They kind of observe the state of the model, report it to us. Is that important? Darn right it's important. If we didn't have that, we wouldn't be running this model. We wouldn't secure insights from it. It'd be full of sound and fury and signifying nothing. Right? We seek understanding from these models, and a key part of that is getting effective reporting. So these are associated with reporting from the model. Very important. Anylogi has rich mechanisms for that, and we started to explore those later. The histogram we created, the time plots we created, the statistics we created. Those weren't used in kind of shaping what the model did in the future. Rather, those were associated with giving us understanding about what's going on in the model. You remember that? Okay. A final thing that I want to emphasize from yesterday may have gone unnoticed. It may have seemed a kind of reactive attempt to sort of deal with the occasional problems that came up. So hands were raised. People asked questions, said, my model isn't working. And various TAs, myself, we scrambled in the room. And I'm grateful to Dale and to I think Ante was helping some, and others who sort of helped, look over people's shoulders and helped figure things out. Now, what was going on there was not merely overcoming speed bumps and kind of dealing with emergent issues in an ad hoc way. What was going on there was a reflection of a reality associated with the modeling process. Things go wrong sometimes. Your model doesn't run. Your model doesn't run. It doesn't even get to the point where it can run. Okay, or it runs and it dies, right? It tells you something that indicates something bad has happened. In the more unfortunate cases, it says null reference exception. Dylan and my eyes brighten. In less forbidden cases, it says something like out of bounds. This thing is out of bounds. In other cases, it may just not display anything. There's nothing happening. There's supposed to be infection spreading, an outbreak supposed to be occurring, all sorts of exciting stuff is supposed to be happening in this model. And it's nothing's happening, okay? And what I tried to impart yesterday, among all the buzz and cacophony of what was going on, the blooming, buzzing confusion of your first day with Anylogi, I tried to impart that there's a method to that madness. That actually, there's orders of magnitude difference between the speed with which someone who has a regularized way of sleuthing down problems with models, how quickly they can find a problem versus others. And in professional programmers, it's a factor of 10 or something between different programmers. And a lot of it is common sense combined with a scientific method, combined with being careful, meticulous, and observing things, and sometimes writing things down. And we'll see if we can talk about that later. But I showed you, I commented, and it may have been lost in the ether, about a couple specific suggestions there. And I want to impart those again because they're so important at a practical level to knowing how to respond. Because folks, unless you know something I don't know, I won't be with you, sitting next to you always while you're modeling. And if you do know, tell me soon. I gotta call my wife. I call my students too, back home. But because of that, it's important that you have some sense of what to do when good models go bad. Right? One thing you do when it ain't behaving properly, you develop a few informal hypotheses for what might be going on, and you try to divide the sense of all possibilities into rough categories. Maybe the model's working, it just doesn't show it. Maybe it's just a display problem. Maybe it's actually not working in the sense that the initial state is not correct. Maybe it's not working in the sense the initial state is correct, but it's just not evolving properly. Those are sort of three broad things. And by dividing things up into hypotheses, you can pursue them. And there's often things you can do that will very quickly check a given hypothesis. Force someone to get in fact and see if you see them as in fact good. Okay, well, at least it's displaying properly. Now let's go and try to investigate what might be wrong. It could be something with the initial state. Let's have it print out how many people are initially infected. And that's the second thing. You have it print out information for you there. I introduced this column to this thing. Yeah. Good stuff. I think that was courtesy of Dylan. The arrow sign on this board.
Oh yeah.
Yeah. Thanks. But we use this call. Does anyone remember what it is? This call is your friend. Okay. Yeah. It's trace ln, and you have to give it something, and what you give it here is something to print out. Maybe it's a variable, person sex, and it will print out male, it will print out female. Or maybe you give it their age. It says age, trace ln of age, it shows it. But more commonly we'll say like, you'll say something like this. What is this? That's me. That's me. That's my name. It's a reference to me. So if I say this, it'll sort of print out. And I'm going to say plus. That's actually it's not an addition. It's a string concatenation. So it's going to turn this into some name for me. Plus, has age. And I'm gonna do plus my age, and this will print out like population member 3 has age 2. Or you might just want to say, I'll tell you what one of the most favorite things for me to do is. I don't know, you might be scared about that. But it would be you just say trace ln, and you give it some recognizable thing. $1 or something like that. And if this thing prints out, it's gotten to that point. Why would you be interested if it got to a point? God, this is something kind of weird. If it got to a point. Meaning, is a transition invoked? Let's go check this out. Can we check it out? Yeah. Okay, so for example, this transition. Look at that. Do you see what lies before you? Okay, maybe you don't see in the back. Sorry. Okay, let's this is what lies there. Associated with that transition was this message. Do you think that's critical to model functioning? It's actually, the model doesn't care about it in the sense it's for me. It's critical for me to understand and develop confidence that the model's working. So when this transition goes, it prints this thing out. It prints it out upon what? Upon what area of Anylogic? Can anyone riddle me that? In the console. Yeah. Now, the console, the word console has such overloaded meaning for me that it's hard for me to figure out what it means to other people. So that may not be a terribly meaningful term, but in the context of Anylogic, what it means is it means this certain area down here. Do you see this? You see this area? That's called the console. And when I stomp it, it actually tends to disappear. But you can do view console, and there it is. And this thing resulted from exactly this line being associated with a given transition, with this transition here. And so that gives me confidence that that transition's occurring, that that transition is being reached. That actually somewhere in the model this is firing. And that gives me confidence that, okay, well, at least that part seems to be going, it seems to be moving. That part is moving in the model. And you know, I could put similar things, for example, on the entry action to this. I could put in the you know, on other transitions. I could put it here, what have you, and it could print out information for me that's useful for me to know what's going on. Develop confidence that this model is working as anticipated. And then later I strip these out. And we have a tool which automatically can insert those and strip them out when you don't need them. But it's a very lightweight way of trying to figure out what the heck is going on. So if you're trying to figure out why your model is not behaving as in the expected way, or even if you're just trying to get confidence it is behaving in the expected way, you can go and you can insert these things. They're very lightweight, and it will print things out and perhaps give you peace of mind. Does that make sense? Okay. And that, I guess, is itself draws on knowledge that we had that we're inserting code in many places of this model. Anylogic is in large part a declarative model building environment, and that's what I think gives it a lot of its power. It's about power to serve as for models to serve as a boundary object, and its power to communicate to the modeler, let them focus on what is being characterized. It's the fact that you can kind of draw things out and fill in the little pieces and still have a high-level view of what's going on visually. And even at the level of small mechanisms, you get a great deal of power out of replacing long volumes of code with pieces that are declaratively specified. For example, here, the fact that we can just say the line color of this thing should be given by color, fill color by color. The fact that we don't have to go write lots of code for this is really great for us as modelers. It enhances our productivity. Here, we see that a lot of things in Anylogi, you just say, let it be this way, and it takes care of that. And that's very distinctive. It's very distinctive, and it's very forward-looking, frankly. Good. So those are some features of Anylogic that came out of yesterday's discussions. Maybe I'll just ask, before we get started, we have some exciting stuff this morning. But before we get started, do you have any questions you want to bring to the table? Yeah?
Hi, while we're still on parameters, I was just wondering, how do you decide whether something should be a parameter set in the population, or if it should be variously set in the stuff?
Okay, so great question. So the question, as I understood it, is there's these things called variables and these things called parameters, and both of them hold values. Hold values for things, and how do you decide if something should be captured in a variable or in a parameter? Well, I would look to a couple characteristics as shaping that position. Okay, I'm not going to give you a hard and fast rule that always applies, but I'll give you some rules of thumb. Okay, some heuristics. Number one, is it something that is a sort of characteristic of that person that's more or less static? It's it rarely changes or it doesn't change at all, right? In that case, encoding it, and by extension, is it something that's kind of set, and the person, is first brought into existence in the model, maybe at the initial model time, maybe when they're born, and from then on it sticks as a characteristic of them. If so, parameter is particularly appropriate for those sort of things. Another thing, though, is it doesn't need to be dictated to that thing from somewhere outside at the point of creation. Even if it evolves a little bit, does it need to be dictated at the time of creation as an assumption for this object? If so, it should be captured as a parameter typically. another thing is it calculated internally as just kind of a passing, over time it's calculated by different processes and it holds a value for a certain amount of time and then changes and it's dictated by different components of the model, like those state charts we saw yesterday. In the state charts it was setting variables. If so, it'll be I'd say a variable is kind of most obvious there. I guess another thing is if it's a derived quantity, if it's a quantity that is in itself provided from outside, but is kind of based on those things provided, I used a variable for that. So it's kind of deduced or calculated based on other things. I would use a variable. For that, it's not something provided up front again, it's something that's kind of deduced later. Those are things for which I'd use variables. If it's an aspect of the plumbing of the situation, like color as a thing, often it's kind of not part of the domain model. It's part of kind of the artifact of how the model presents things. It's not part of kind of the world. I often will use a variable more in that context. But I mean, I have no inherent ideological problem with saying, let the color be a parameter so I can dictate it at the time the agent's created. Yeah, sure. It's a pragmatic matter in that sense. Does that help at all? I mean, those are some rules of thumb. Yeah. Sorry? Yeah. Well, I think you'll find a variety of subtleties in it, but those are some of the key ones. So probably a lot of those would unite a lot of people in how they use them. Because remember, parameters. I'll get to you in just a sec. Parameters capture two functions. They encode an assumption and they communicate that. If you have a variable, you cannot dictate its value easily from the point of creation. Okay. So let me make this point. So here we have this person, and this person is a color as a variable and a contact rate as a parameter. Okay. Now, watch this. If I go to the population that includes that person, and I go up to what values should be used, you notice that the contact rate here is specified. That's the parameter. There's no option of specifying the value of the variable. So if you want at the point of creation to somehow specify the value of the variable, you have to put in place extra mechanisms, and it's just extra painful. So parameters are used to communicate this information from the point of creation to it. And the same thing is true if you have a variable name. Sure, can you have variable? Yeah, in fact, we often do. Count the number of people that have ever gotten infected across the entire population, or whatever it is. But you can't set that directly. You can't set that nearly as easily from experiment. It's the parameters that are the conduits for specifying the assumption. Yeah.
So if we choose to initialize something like a rate within the agent itself, would the distribution act differently at all?
No, you could do that. It would be perfectly fine. So in other words, suppose you wanted to compute the rate endogenously within the agent. Maybe it changes over time. Maybe it's just computed up front for some reason, but not as part of the population. No, it would be a perfectly fine option. Would work great.
Overall, the population should still look like a distribution.
Yeah, absolutely. You could take all the characteristics, if you don't care about more than one population and so on, all the assumptions about the population that we used yesterday, like let's say for this one income, no, it's not that one, a simple income one. If we had said, okay, could we take these assumptions about the population, this age distribution, the sex, and income, and could we instead sort of impose them on agents from within, so they're kind of inherent characteristics of personness? I would get a little bit of the heebie-jeebies, and I would feel a little bit uncomfortable because I don't think of the particular values of a particular distribution of ages as inherent to personhood. But could you do it mechanistically? You bet you could. Are there cases where it would make sense? Yeah, yeah. I mean, maybe it is something close to the person, but like the, I don't know, the fraction of people who are left-handed or something like that, right? Or the number of people who have certain genetic characteristics. I mean, it's not something that varies perhaps significantly among populations. Could we determine those within the agent? Yeah, in fact we could. And I would do that with a variable thing, or a parameter.
Yeah, say that, the way that, like, you can reference the sex after you set it from income, but if you wanted all of them to interact together and different functions, then you really can't do that from the population.
Well, yeah, I mean, it's done in a staggered way.
Yeah.
So you know, you specify one first, then the other can depend on that, and then the third can depend on the first and the second, in sort of a conditional way. But if you wanted something to depend on all of them together, or it's a very tangled sort of set of relationships, I would say it would be easier to do within the agent. And I understand completely the pragmatics of that. You know. Be aware, though. I'll give you. Take it from an old man. Some of these hairs, well, they're not white today. Some of them are white due to repast, probably. Anyway, the fact is that parameters and variables are initialized at somewhat different times. So I think the parameters have values before the parameters are associated with values before the variables are calculated. I think that's the order. I have it down on my slides, I swear. But in any case, they're computed at different times. So don't count on the variables already being set by the time that you're trying to do something with a parameter or what have you. You have to be careful about the different times, the staggered nature of their initialization. And if you want, we could go, you know, get specifics on that. But. Okay. Yes.
I have a couple of questions. One, what are the limitations of the software? So, for example,
the limitations.
If I was interested in modeling really complex system,
yep.
Composed of several networks, which are in itself maybe a bit larger than what we've seen in the workshop so far.
Yeah.
So how would this cope
with the sizes?
Is this possible? Has it been done?
Sure.
Has it been used successfully? And second question is statistical capabilities. So
right.
In terms of the output, what can I get
Great.
out of it apart from seeing things?
Wonderful question.